This page is in your notes and it serves as a great reference for the method of solving quadratics by completing the square. I'm going to read this with you and we'll look at this example together. So, completing the square. One method for solving a quadratic equation is by completing the square. And there's just an example here. Solve for x by completing the square, and you can see there's the x squared plus 6x plus 1 equals 0. And you can see that they've already taken the x tiles, and there's 6 of them, right? And they've divided them into two groups, half of them going off to the right, and then half of them going up above. So that's why we're always taking this number 6, the coefficient of x, and we're dividing it in 2. And then you can see there's 3 off to the left, 3 off to the right. And the next thing we end up doing is we end up squaring that at some point and adding 9 to both sides to complete the square. So first, use the algebra tiles or an area model to determine if it is already a perfect square. Since x squared plus 6x plus 1 is not a perfect square, rewrite the equation with the constant term moved to the opposite side and a blank in its place. So that got migrated over. And then using algebra tiles shown at right, make a complete square for the left-hand side of the equation. Determine the number of unit tiles needed to build a complete square. In this case, 9 tiles are needed. This means that 9 needs to be added to both sides of the equation. Notice now that since this is a square, right? It's an x plus a 3 times an x plus 3. That's why we can rewrite this as x plus 3 quantity squared. And on the other side, it was a -1 and then plus a 9, so we write that down as root 8. So again, we don't expect it would be silly to walk around with a box of algebra tiles all the time, but this is just to help us visualize what we're doing. The mechanics of what we've been looking at is when this coefficient of our squared term is 1, we're taking this number and we're taking half of that, and then we were squaring that, and that's giving us the value that we have to add to each side to complete the square. And when we add, in this case, the 9 tiles, right, we now have a perfect square. And what's nice about that is that we can write this as a perfect square, right? X plus 3 quantity squared. That allows us then to take the square root of both sides. And you don't see this step here, but when I take the square root of x plus 3 quantity squared, that's exactly the same thing as the absolute value function, right? If you take any number, and I don't care what the number is, if you take 7 and you square that and then you take the square root of that, you're going to get 7. And if you take -7 and you square that and then you take the square root of that, you're also going to get +7. So in each case, it doesn't matter if I start with a +7 or a -7, I end up with +7. Well, that's exactly what the absolute value function does. So it doesn't matter what you put inside of there. Um, if you put a positive, I'm sorry, if you put a +7 in there or a -7 in there, you're going to get an answer of 7. So same thing's happening over here, right? We're getting rid of this the square root of a perfect square, and we're just switching it to the absolute value. And then we realize, look, there's two things that this is. If I have the absolute value of x is the number 7, there's exactly two things x could be, right? X could either be +7, right? This thing positive, or x could be the opposite of that thing. And that's what's happening here. We've got the absolute value of something equals the square root of 8. Well, that could either be the positive version of that. It could x plus 3 could either be positive root 8 or it could be the negative root 8. So that's exactly the mechanics. And then you can see we went ahead and subtracted 3 from both sides. And then this is super nice, right? This is the simplified radical form of root 8. That's the same thing as 2 times the square root of 2, because the square root of 8, right, is the same thing as the square root of 4 times the square root of 2, which is 2 root 2. So this is our answer. This is the exact form of our answer. And I will continue to ask for you to give me the exact answer, but then also you can see we have the decimal approximations here as well.